Educational GMAT. Your partner in your GMAT journey.
This is slightly difficult. I'll give you guys actually good 5 minutes for this. Again, this is an official question, by the way. There are 27 different 3-digit integers that can be formed using only the digits 1, 2, and 3. If all of the 27 integers are listed, what would their sum be? First of all, do you agree that 27 different 3-digit numbers can be formed using the digits 1, 2, and 3? Do you guys agree with this? Yes. Why?
Order that it will be repeated, so 3 and 3 and 3.
Absolutely. Notice any of the 3 can come here, any of the 3 can come here, any of the 3 can come here. So total number would be 3 into 3 into 3, which is 27. Correct? Which would be those 27? Which would be those 27? For example, it would be, let's say 1, 1, 1, right? 1, 1, 2, 1, 1, 3, and so on till 3, 3, 3, right? The question is asking us, what is the sum of these 27 numbers? So this is what the question is asking us. What is the sum?
162.
Oh, that I think is very, very underestimation. Yeah, that was the word, underestimation. Oh, it cannot be 162, right? Because this alone is 333, by the way, Chatrika, right?
Okay.
We are talking about sum of all these 3-digit numbers.
I assumed that it's different 3-digit number. Okay.
These are different.
I did not take into consideration the repetition.
Okay.
Yeah.
So there is another concept that I wanted to make sure we understand. For example, let's say there is a 3-digit number 246. Now, what does it mean 246? 6 is in the units position. This is in the tens position, and 2 is the hundreds position. What does it mean 2 is in the hundreds position? 2 is contributing a total of 2 into 100. How much is 4 contributing? 4 into 10. And how much is 6 contributing? 6 into 1. So that gives us 246. Are we clear with this? Okay. Now let's come to, so with this understanding, let's come to this question now. There are a total of how many integers? 3, right? Total of 3 digits. And total of 27 integers that are formed using those 3 digits, right? So purely think about it from a symmetry perspective. Out of these 27 total, right? 27 digits, tell me one will be in the hundreds position in how many of these digits? Did you get me? Total of 27 integers using 3 digits. Very nice. total of 27 integers using 3 digits, right? So my question is, 1 will be in the hundreds position in how many of these? 9. Similarly, 1 will be in the tens position in how many integers? 9. Similarly, 1 will be in the units position in how many integers? 9. Correct? So by virtue of the digit 1, how much is it contributing to the entire sum? Well, 9 times 1 appears in the hundreds position. 9 times 1 appears in the tens position. 9 times 1 appears in the units position. So this is the total contribution of 1 to these 27 integers. Similarly, now let's take 2. 2 will be in the hundreds position. Hundreds position in how many integers? 9. 2 will be in the tens position in how many integers? 9. 2 will be in the units position again in 9. So which means how much is 2 contributing? 9 times 2 into 100 plus 9 times 2 into 10 plus 9 times 2 into 1. Right? This is the total contribution of 2 being in the hundreds position, right? This is the total contribution of 2 being in the tens position. This is the total contribution of 2 being in the units position. And we can do the same exercise for 3, right? So again, 9 into 3 into 100 plus 9 into 3 into 10 plus 9 into 3 into 1. And now what do? We add all of these. Kavita? Because 1 appears in the hundreds position in 9 integers. 1 appears in the tens position in 9 of these integers. 1 appears in the units position in 9 of these integers. Are we clear? Another way to look at it, if this is not very intuitive, there, notice these are 3-digit integers, right? 1 appears here, right? 1 is here. So how many choices do we have for the second position? Any of these can come here. So 3 choices. How many choices do we have for the third? Again 3. So then what do we have? Total 9. I don't remember the answer, but that's big. So this calculation is not as intensive as it looks like, because you obviously can take a lot of things common. But is the approach clear, guys? Is the approach clear? Okay. So 100 plus 10 plus 1, you can take common. And yeah, this was the answer that you were getting, Isha. Very nice. So 5994 is the final answer.